Dear participants, good evening. Am I audible? Is my screen visible? Yes, good evening. Good evening. Yes, thank you. Thanks for the confirmation. So I hope we can start with today's class. And in yesterday's class, we are in the middle, right? So we haven't completed some topics. Remember, guys, what all things we have seen in yesterday's class? We have seen about train test split, and then we moved into feature selection, right? So in feature selection, we have seen few methods, and we are going to continue with that. Remember what are the two methods we have covered? What is that? Tell me, guys, in the chat box quick. So in today's class, we will be completing the remaining methods present in feature selection, and then we will be starting with machine learning algorithms. Okay, so I have just rephrased the plan actually. So earlier I thought I could take the classification algorithm one day and then see the classification project, and then regression algorithm one day and then regression project, and then now I thought it would be a better plan if we see all the algorithms together in today's and tomorrow's class. So with that, by tomorrow we can complete the algorithms, and from Monday onwards, from the day after that, we can start with the projects. Okay, so that's what the plan is. So today we'll cover the remaining topics, and then we'll start with machine learning algorithms. So we'll see what is the math or what is happening behind the algorithms in today's and tomorrow's class. Okay, so after that we'll start with machine learning project. So what all things we have learned till now, we'll apply that and see and how to get the result and so on. Yes, in yesterday's class we have seen what are the two methods. Remember, guys? So one is correlation method, and what is the name of the other one? It is dropping the constant features with the help of variance threshold, right? By setting a threshold value. So next, okay, so in machine learning we have seen completed the data collection, pre-processing, train test split. Okay, feature selection we are in the middle, and we are going to start with model selection, what all things behind it in today's class. So in feature selection, so we have seen about the features. So these are the methods like dropping the constant features with help of variance threshold, then using correlation method, removing the columns which are very highly correlated, removing that. Then we are going to start with mutual information, chi-square test, and Anova F value. Okay, we'll complete these three now. So starting with mutual information. So it is a statistical measure that tells how much two random variables are related to each other. Okay, the value of mutual information will be 0 if the two variables are independent. Okay, and the value will be high based on their dependency, which means if there is no relation, this value is going to be 0. And if they are highly related, we are going to give some value high. Okay, and this mutual information for classifier and regressor is available in sklearn. So based on the project you are doing, so if your target is a classifier, is a classification project. So what is a classification project? The output is discrete, right? So it can be yes or no, or like in flower we have, right? So what is the species we are going to predict? The prediction column, whether it is Setosa, vesicular or Virginica, or when you go for Titanic dataset, whether the passenger is survived or not. So it is like a selecting in the discrete output. So for that you can go with this classifier option from sklearn.feature_selection, import mutual_info_classifier. Okay. So you can create an object for it, and you have to pass the x train and y train value. So what will happen is, see here, it is going to compare the x value with y value. So if you are having 4 columns with x, okay, imagine the iris data set, we are having 4 features, right? And we are having the y column here. So it is going to compare each column with y and give the value. So finally you can get some values. So based on it, if the value is high, it is going to be there is some relation between the output and that column. The lesser the value, that means it is not that much related to the output prediction. Okay, so that's what this mutual information classifier will do. So we'll try to do this, right? In collab, can we start, guys? So I'll import the necessary libraries. Import Pandas as PD, import NumPy as NP, and import Cbon as SNS. Okay, it's done. Now see here, I'll load the iris dataset like as I did before, sns.load underscore dataset. And remember guys, today is day 10, so I'll be giving one assignment, so make sure you attend the class till end. Okay, so today I'll be giving you the assignment 2 based on the topics which we have seen in previous classes in the past 5 days. So these are the things and this is the output. Okay, so what I'm going to do in X, I'll call iris.drop the species column, which is the axis here, axis as 1, right, since it's a column wise action. And in Y, I just store iris.species. Okay, iris.species, I'm going to take it. And from sklearn dot model underscore selection, import train underscore test underscore split. Fine. So now I'll go with the train test split. I have to create 4 variables, right? We have seen in yesterday's class. X train, X test, comma Y train, Y test is equal to, so I have to call the train test split module train underscore test underscore split. And X, Y test underscore size, I'll set this to 0.2, which is nothing but 20%. And random underscore state, I'll set this to 42. Okay, I'll run this. Now what I'm going to do, I'm going to take the X train and Y train value and I'm going to pass it inside a mutual information classifier. So this mutual information classifier is from sklearn dot feature underscore selection, import mutual underscore info underscore classifier. This is for classification problems. Okay, this is the classification. It is 3 types, so we are going to find which type it is. So now this mutual information classifier will help us to find how this column is related with the species, how much this column is related with the species. It will do the math and give you the value. So if the value is greater, which means it is highly related, and if it is closer to 0, it is not that much related. Okay, so with that we can filter. So I'll create a variable mi mutual underscore info underscore classifier. So I have to pass this X train and Y train value, X and Y value. So once it is done, I'll create a series with it. Okay, so for our understanding, so I'll call series and pass this mi and store it in mi itself. So I'm going to set this index, and this index will be the column name. So xtrain dot column will be set as index, and I need to sort it based on the highest value. So sort underscore index, sorry, its values ascending equal to false. So let me run this and see here we got the column names and the value. Okay, this is the mutual information value, and you see here the petal width is highly correlated with the output column. Okay, this has the highest score, and this sepal width has the least score, which means it is not that much important for the prediction in this sense. Okay, so now you can use these values to filter it, which means the lowest you can take it. To take something out, you can do this option, which is from sklearn. There is something known as k-best. See here guys, this is new one, k-best. So this is from sklearn.feature underscore selection, import select k-best. So if you pass the value as 5, for example, in this context, I'll tell, okay, in this iris data set, I am having 4 columns. I want to take the first 3, which means the most important 3 column. So I can set the k value as 3 here. See here, k value as 3. I can just call this select k-best and pass this mutual information classifier inside of it. And I can call it to fit on the X train and Y train value. When I use this get support, it is going to give me boolean of true and false, which means wherever it is true, which means that columns are accepted, and if it is false, it is not that much important in this sense. Okay, Can we try, guys, with select k-best? Can I get thumbs up? We got the result with mutual underscore info, okay, but we are going to use select k-best to actually filter it. So it's best method because this k-best is mostly used in further processes. When you go for chi test or Anova test, we'll be using this also. Are you guys there? Can I get thumbs up in chat box? So I need this thing. Along with that, I need import select k-best. Okay, so select equal to, I'll call this select k-best, and I can inside this I can pass it as an argument. Which type it is information classifier. Okay, and the k value I'll set this to 3. Okay, so once I set this to 3, I have to just fit the data. Select dot fit x train comma y train. Okay, so let me run this. Now it's fitted. So in this variable select, you can actually go and get select dot get underscore support. So as we see in yesterday's class, this get support will give you a boolean of true and false. If it is true, then you can take that actually. Okay, it has given true, false, true, true. Okay, I have asked for the 3 best value, so it is giving me a boolean which is selecting 3. I got true in 3 places. So what is this false actually? If you go and get x train dot columns sepal length got true, sepal width got false, and remaining got true. So which means it is asking us to neglect this sepal width. How it is telling? Can you see it, guys? Sepal width has the lowest score, so that's why it is neglecting that column. Clear how this thing works? Okay, I am asking for the best 3. If I go for the best 2, okay, it is going to leave the sepal length and sepal width, and it will ask me to take this petal value alone. False, false, true, true. Okay, petal length, petal width, sepal length and width, they has the lowest score, so it is asking me to neglect that. Instead of selecting using the k-best, you can also go with percentile. So instead of select k-best, you can call this select percentile. So if you pass some percentile, based on the percentile, if you are having many columns, for example, in that previous example we have yesterday like 370 columns, right? So you can go and mention the percentile, so that much percentile will be selected and the remaining thing will be eliminated. Okay, it's the same process. You have to fit it and get the support and do this process. And for regression, okay, you can call any regression. When you go for regression problem, you can use the same, but this is mutual information regression. Instead of classification, it is regression. Okay, clear? You can do the same thing. You can either go with select k-best if you want to choose according to the k value, or you can go with percentile. This is for regression problem. When you handle regression problem, you can do with this one. Okay. So next we are going to see about chi-squared test. So this is a statistical test that can be used for feature selection. So it is commonly used to determine the statistical significance of a feature's relationship with the target variable in a classification problem. So this is for classification problem. Okay, so it is also going to find the relationship with the output. And to use this, okay, you can go and get from sklearn.feature selection import. You can import both of these. This chi2 will be the chi-squared test. Okay, so instead of this mutual information classifier or regressor, you can here directly pass this test. Okay, so it is going to do that and give you the output. Okay, so I'll do this here. I'll copy this. So I just want to alter little bit things here. Instead of mutual information classifier, I'll import chi2. So I'll pass it here. So let me get the top 2 variables here. So I can run this. It is the same. So you can go with select dot. See here, it is function. This is happened. Select dot get underscore support. Okay, so false, false, true, true. So you can use it as a filter also, even to get the actual columns you need to use. For example, you can pass it like x underscore train dot columns. Okay, so it is going to give you what all true, which means you have to take this petal length and petal width. So it is telling me these two are the best. Okay, based on this G2 test. Clear? Clear, guys? So we can pass this also as a filter if possible. You can see here I can take that alone and store it in a different variable and do further process. Okay, and similarly there is another test which is Anova, which is analysis of variance. It is also a statistical method used to test the difference in means between two or more groups. So it is working by comparing the variance. Okay, this is by comparing the variance between two or more groups and identifying the features with significant difference and ranking them based on the F score. Okay, so to use this, these are all some kind of statistical methods. Okay, so from sklearn.feature selection, import select k best and f underscore class f. So this will perform the f test, which is also called as Anova, which is analysis of variance. Okay, so you can go and fit the data, pass this inside the select k best. You can go select k best or percentile based on your requirement. Okay, you can do the same thing, you will get the output. So for this, okay, wait a second, guys. So we'll try to use some other data set. Okay, so let me go and get some data set, different one, sample data set. I hope we can use this hard data. Okay, so why are we using the same data set? We can try this one with different data set. So I'll copy the path, path equal to pd.read underscore csv head. Okay, so finally we are having the target column and all these things in numerical value. You have to scale it, but I'm just directly going into the train test because I want to explain this thing alone. Okay, we'll try according to the hierarchy when we do the project. So drop. So I'm going to drop target. Okay, and the axis is 1. And in y, let me call target. Let me run this. Okay, so x train, comma x test, comma y train, comma y test is equal to train underscore test underscore split. I have to pass this x comma y comma test underscore size. I'll set this to 0.2 and random underscore state. I'll set this to 42. Okay, so now I have to use the same thing, but instead of this G2 test, I can do this also. Now I'll go with this Anova test. Okay, so that is nothing but f underscore class f, right? Okay, so I'll pass. I want to select. So totally how many columns in x dot columns or x train. X underscore train dot columns x underscore train dot shape. So we are having these much columns, right? So I want to select some important columns alone. Okay, for example, so totally it has 13 columns. Okay, so I want to take only important 6 columns. Okay, so now what I'm going to do, I'm setting the k value as 6. So and the test I'm going to pass is f class if, which is Anova test. And I am passing the x train and y train values now. Okay, so now I can go with select dot get underscore support. Okay, so it is giving me boolean with true false in many places. So I can pass it as a filter now to x train dot shape. Sorry, it's columns. Sorry, it's columns. Okay, these are the important features, 6 features from that 13. Okay, can you understand? This column CP, okay, all these columns will peak the level. So these are the important features for selecting the target. So that's what it is giving. Clear? You can pass the C2 test also here. Okay, it is giving cholesterol, this column, and these columns are very important. Okay, the best 6 columns based on your features, relationship with the output. So that's it guys with feature underscore selection. Can we start with machine learning algorithms now? Can I get thumbs up guys? Is it clear till now? Regarding machine learning algorithms, if you want to start it, okay, there are many algorithms available. See here, each of these things is an algorithm. So the question comes, how to choose the right machine learning algorithm? Okay, now we are going into algorithm and we are going to choose. Okay, so we are going to decide how to choose the right machine learning algorithm. How will you do it? So you have to consider these features like nature of the problem you are going to solve. Okay, hard data set, you can download it from Kaggle. You can search it. So in the previous classes we have thought about how to collect the data. So it will be a really helpful training for you to collect the data actually. So the factors you want to consider is nature of the problem. Okay, the problem or type you are going to solve. I'll explain this individually. Then going into nature of algorithms. Okay, so what is the algorithm type? Okay, based on it. And then performance comparison. This will be the final thing. Okay, starting with the nature of problem. So see here guys, the machine learning you have to decide them based on the types of it. So the machine learning is split into 3 types, right? Supervised learning, unsupervised learning and reinforcement learning. So focus on the supervised learning first. In the supervised learning, what is the meaning of supervised learning? I have told you in the introduction of the machine learning class. It uses labeled data or unlabeled data. Tell me guys quickly in chat box. Supervised learning uses labeled data or unlabeled data. Tell me guys, this supervised learning, which means it is using labeled data, which means it has a feature and there is an output column which it just want to map the output. Okay, and in unsupervised learning it uses unlabeled data because we are going to find some cluster or trend inside of it. So when you come inside of the supervised learning, there are 2 types. One is classification, another one is regression. So what is classification? What is regression? Okay. So based on that, for classification we are having separate algorithms. For regression we are having separate algorithms. For example, see here, decision tree is a common. So there are some common algorithms also which offers. For classification they offer different one. Okay. Random forest or decision tree classifier. For regression they offer decision tree regressor. So what is the difference? Okay, so we'll see about clustering later on. It will be separate. So first our focus will be mainly on supervised learning. We are going to see clustering, but it will be in a later part. First we'll focus on these algorithms and complete this project. Okay, so what is supervised learning? It is the type of machine learning which uses labeled data. So this labeled data are some input data already tagged with some output. Okay, so the machine want to just map them correctly. So it is like a teacher who monitor the student how to like map it correctly. So it applies the same concept as a student learns in the supervision of a teacher. So what is classification and regression? Simple example guys. See here. What is classification? You want to classify. This is a binary classification, which means the output is either this or that. 2 label. Okay. So you are going to predict whether it is cold or hot. If means you are going to give the output either it is cold or hot. Okay, this is discrete. Okay, this is known as classification. You want to split them either it is cold or hot. What is regression? What is the temperature going to be tomorrow? You are going to predict a value. This is a continuous output. This is a discrete output, either this or that. But here, for example, temperature prediction or the salary prediction, which is not going to be this or that. It will be a value. It is a continuous value, right? So it may go or keep on increasing or decreasing. So based on it, you have to decide whether your problem is classification or regression. So for that, you are going to choose separate algorithms. Next thing will be nature of the algorithm. So if you are going to use or select an algorithm, you want to know which is the use case of that, when you should use it, what is happening behind it. You just cannot do something, apply it and get the output. It won't be good, okay? So a perfect data scientist who should know, okay, he should know what is happening behind of it. So we'll start learning one by one algorithm, okay? We'll try to cover 2-3 algorithms today. So remaining thing we'll cover it in tomorrow's class. With that, we can go with the project later on. So starting with the first algorithm, linear regression. Can we start it, guys? Anyone heard of it? Linear regression? Is it clear till now? Can we start with linear regression algorithm? So I'm going to talk some statistics and maths behind of it. So please make sure you are listening properly so that you can understand what is happening actually behind it when you call this. So why we are using it. Yes? Okay, starting with linear regression. Listen guys, linear regression is a popular and widely used supervised learning algorithm. So it is for regression problems. So it is a statistical method that models the linear relationship between a dependent variable and more independent variable. Okay, they are telling linear relationship. What is meant by linear? Straight line. Okay, so we are going to refer some maths which we have learned in our school days. So linear regression makes predictions for continuous or real or numeric variable like salary, sales, age, product price, or like this temperature. Okay, it is a continuous variable prediction. You can go with linear regression. It is going to be like this. So what is that? This is what a graph of linear regression. Okay, so for example, you are taking two columns. One is an independent variable and another one is a dependent variable. So what is meant by independent variable? What is a dependent variable? Dependent variable may be the output. Okay, for example, the temperature or the price or the age. Okay, independent variable may be your features. Okay, these are x value, this is the y value. We have done it right, x train, y train. Okay, imagine only one column and you are plotting it. You are doing a scatter plot. So you have got a scatter plot. And what this linear regression will try to do is it will try to find a trend, okay, using a straight line. So what is a trend? So from this, what you can see, tell me guys, the value of x is increasing when you go this side, okay? And can you see some trend in the y? What is happening here? When the value of x is increasing, the value of y is also increasing. Can you see it? See this point, the value of x is this. For example, if it is 10, the value of y is also high. This point. So it is linearly, can you see it? This is what known as linear regression. It is trying to find a trend with the help of a straight line, okay, based on the data points. You cannot just randomly draw a point, okay. Based on, you cannot randomly draw a line. You have to draw it, okay, based on the points. So I'll tell you how it is drawn. So what is the best fit? There are some other features, but this is what will happen, okay. So if you give, for example, if you train the model with this algorithm, you are giving some data, right? For example, you are giving 1000 rows. So it will going to give you, plot 1000 points here. So it will try to find a straight line. If it fits actually, if you give a new point, it is going to give, okay, take the x value. If you are giving x is what we are giving, right? So you will give x. So it is going to take the point x. And what is the value of y? It will take the value of y and give you the output. Clear? You are giving a new value of x. So you want to ask the model to predict the value of y. What it will do, it will just do this mathematical thing. It is going to find the value of x, plot it in the line. Where the line is, what is the value of y in that place, it will be the output for you. That's the answer. It can be a temperature or the rate or age or sales date, whatever it may be. Okay. And yes, it is a positive relationship. So what is a positive correlation? Okay, if you draw a line, a straight line, and if the value increases, if the independent variable increase and the dependent variable also increase, it is a positive correlation. If it is a negative fit, which means when the value of x increases, the value of y will decrease. See here, when this is high here, but when it goes, it is going to decrease. If you can't find a trend, it is going to be no correlation. If it is just a random data, you cannot fit a straight line. Okay. And listen guys, this is a use case example. Okay, so this is a car data set. Okay, and we are having these columns known as price. Okay, used car data. So what is a used car? So it is already used and they are going to give it as a second hand car. So this price will be the thing which we are predicting. This is the output. Okay, this is a continuous variable. This is a regression problem. And these are all the features. The age may be how much it is used. The kilometer driven, fuel type, HP, okay, horsepower, the color metallic or not, automatic or not, CC, the doors present and the weight of it. And these all from the age to weight will be the feature and this price will be the output. And at first what I am doing, listen, I am taking this price as the output and thus age alone as the feature X. So what is the age of a car? If the age is increasing, the price will decrease, right? Can you understand what is the logic behind of it? Age is like how much year the car is used. If the car is used for a very long time, then the price is obviously going to be less because only a few times used car will have a high price, right? So I'm going to take these two alone. This will be the Y value, this will be the X value. So I'm just plotting it. So value of X here, value of Y here. So I can see when the age is increasing, the value of Y is decreasing. Okay, I can draw a straight line. See here, age versus price. So the value of X is increasing and the value of Y is decreasing. So this is a negative correlation. Okay, clear guys what is happening here? So how this line is drawn actually, there are many points here and there, and can't you draw some other line here like this? So I am having two lines here, one line is a blue line, another one is a red line. Both of the lines are passing through these 2 points, but how will you find the best fitting regression line? Is it clear till now what is happening behind this regression? Any doubt guys till now? And now the question comes, if you are having 2, 3, you can draw many lines. How will you find which line is the best fitting line? Because if you slightly tilt this line, your output will be different, right? So for example, if I am taking X value, I want to find based on the blue, it will be this value Y. Based on the red, it will be this value of Y. There is a huge difference here. So how to find the best fitting line? You have to go for mathematics for this actually. So there is something known as cost function which uses sum of squared error. So what is that? So see here guys, I'll explain you with this one. So first, the goal of linear regression is to find the line of best fit that can accurately predict the value of the dependent variable based on the values of independent variable. So which means based on the value of X, I want to find the value of Y using the best fitting line. So line of best fit is determined by minimizing the sum of squared error. So you will be getting some value known as SSE. And this value, if it is low, which means the line is a best fit. So for example, imagine guys, I draw a straight line and all of these points are in the same line. Okay. So before that, I'll tell you how this SSE is calculated so that you can understand better. How this SSE is calculated? Sum of squared error. For example, I draw this line, okay, and this point is here, but the line is here, right? So this distance between these two is known as error. Okay, so I can get a error value for this point. I can get a error value for this point based on the distance with the line. Error value for this point, how much it is? For example, if it is 1, this can be 2, this can be 3, right? It is high. So you can take all of this, okay. You want to square them. So that's what it is. Sum of squared error. You take the error distance, square it, and then actually add all of those. Okay. When you add all of those, you will get a value known as sum of squared error. So imagine guys, if you got a straight line and all the points exactly fit with the line, what will be the value of SSE? You have a straight line and all the points are exactly in that line. Will there be any distance? No, right? So if there is an exact match, so the value of SSE is going to be 0. Okay, so which means if you have 2, 3 points, you go and calculate the SSE for both of this line, which has the lowest SSE value, okay, or the cost function, which has the lowest value or near to 0, that is the best fitting regression line. Okay, understood? Is it clear how? If you have a straight line and all the points are fitting exactly, the distance between both is 0, which means if it is 0, if the value of you got sum of square error is 0, then it is the best line. So it is not actually possible when you are going and fitting a multiple points here. It is not possible to exactly fit. So what you can do, you can draw some line which has the least number of SSE value. Okay, I got this blue line and red line. For example, if I got this red line has the least value of SSE, then this will be the best fitting line. Okay, so based on that I can take the output. Clear? So the line passes exactly through all the points, then the value of SSE will be 0. So by comparing the SSE value of all the line which has low SSE value will be the best fitted line. And coming back into this straight line. So I told you, right? The straight line, what is the equation of a straight line? Y equal to mx plus c. So this is what exactly the machine learning algorithm is doing. So in sklearn, okay, we are having in linear model, we have this linear regression, which is for regression problem. You can use the model. If you just pass the x train and y train value, it is going to give you the output. But what it is happening behind of it, this thing is happening. You are not actually going to find the SSE value and compare which line is best. Your model will actually do. The algorithm will automatically do this. Okay. But how it is doing, this is the math behind it. And for example, the linear regression algorithm will try various combination of m and c value. So for example, see here, y equal to mx plus c. Y is the value which we are going to predict. Okay. What is m value? Okay, m is the gradient difference in y. For example, 2 points. This will be difference in y. This is difference in y. y2 minus y1. This is y2, this is y1. This value, okay, this difference in x will be x2 minus x1. x2 minus x1. This value, when you divide it, you can get a x value. Sorry, m value. Okay. If you draw a straight line, for example, you are drawing a line which is low. Okay. You can draw multiple lines. So the algorithm will try to do for every line, it is going to get y value, m value. Okay. What is c value? It is a y intercept, which means when the line passes through y, what is the value of y at that place? If it is 2, you are going to substitute the value as 2. Okay. So the algorithm, what will do is, it will try to find, okay, it will try to fit many line, okay, it will try to fit many line with various combination of m and c value. If you change the value of m and c, you are going to actually get different line. Or if you draw different line, the value of y and c, m and c will be different. So it is going to draw different line. So which has the lowest SSE, that will be the best fit. So this is done with the help of algorithm itself. You don't have to worry about it. This is what happening behind of it. So till now I have used only one column, right? Only age versus price. But here there are other features also. So if I pass all these features, it is going to be sum of it. Okay. So this is the same y equal to mx plus c. This is the c value m multiplied by x. Okay. Don't get confused. So this c value will be a constant because you are drawing only one straight line which will pass through y intercept. But this value, if you are having, this is the age. Okay, for example, this is the age feature. This is like the petrol type. This is like the kilometers driven. So whatever the features, okay, you can add it, and this will be the multiple linear regression. If you pass many columns, it is going to do this task only. Is it clear, guys, till now regarding linear regression? Is there any doubt? Any doubt how this linear regression is working? Can we see this logistic regression alone in today's class? So regarding logistic regression, so linear regression draws a straight line and it is for regression problem. And this logistic regression, it has the name of regression, but it is for classification problem. Okay, it is not for regression, it is for classification problem, and it will try to fit a shaped curve. So what is happening behind of it? So logistic regression is much similar to a linear regression, except how they are used actually. Okay, linear regression is used for solving a regression problem to find a value actually. Based on the straight line, you can fit a point and you can get the y value. Okay, But this logistic regression is used for classification problem, okay, either this or that or multiple class. So how this is happening? Instead of fitting a regression line, we can fit a S-shaped curve, okay, which predicts the two maximum values, 0 or 1, or based on the output features. So if the, like in classification, okay, so if there is only two possible outcomes, then it is binomial. And if there are like cat or dog or sheep or like separate things, like the iris dataset species, right, 3 different one, then it is going to be multinomial. So this logistic regression, and remember guys, for this logistic regression, okay, this is for classification output either 0 or 1, and there are some other algorithms also. So if this is a binomial thing, which means the output is either this or that, okay, if it is binomial, then you can use this logistic regression. If it is multinomial, you can go with some other algorithms which are actually better for this kind of tasks, okay. So this is a Titanic dataset, you know this, right? And I have taken these columns and the output is survived, either 0 or 1, that's the output. And see here guys, if I try to do a scatter plot with this survived, okay, survived in y-axis, and for example, like some other column, okay, fare, or passenger class, or any column with this survived, if I go with fare and survived, okay, in y-axis it is 0 and 1. So what will happen? The points will be plotted here or here, because the y value is these two only. With that, you cannot draw a straight line here. So that's why in classification problem, we are actually going with a logistic regression which tries to fit a S-shaped curve like this. It tries to connect both of these points. And we are going to use a threshold value, which means it is 0.5. Okay? It is 0.5. So what will happen is, when you try to fit a point here, the value of y will be 0.8. If it is greater than 0.5, it is going to be given as 1. If it is less than 0.5, it is going to be given as 0. So this will be 0.3 means it will be actually 0. So when you use logistic regression, it is going to give you a probability of 0 or 1. Which means it is not actually giving 0 or 1. It is giving you a probability. With that, if based on the threshold value, if it is greater than this, we are selecting it as 1. And if it is less than this value, we are considering it as 0. The sigmoid function, S-shaped curve, is also known as sigmoid function. Okay, it is a mathematical function used to map real value to another value, either 0 or 1 with the help of S form. So the S form curve is called a sigmoid function. Okay, it is just giving you the probability either 0 or 1 based on the value we are deciding. So this is the formula actually behind of it. Okay, and see here this B0 plus B1x, this is nothing but y equal to mx plus c. This is c value, this is mx value. Okay, we are taking this e power this and we are dividing it with 1 plus this value. So this will give you the y value. So based on it, we are actually giving the output. This is what happening behind the logistic regression algorithm. And remember, linear regression is for regression, logistic regression is for classification. Clear regarding logistic regression? Is it clear guys, what is happening behind of it? So we'll see the support vector machine in tomorrow's class, okay? So with that, we have to see some other algorithms, like there are some tree-based algorithms like decision tree, random forest, and then ensemble techniques, boosting techniques, bagging techniques. Those things will be discussed in tomorrow's class. And we have to also see about the metrics or the model evaluation. So that will entirely cover all the separate topics. And with Sunday, we can actually go and take a project. For example, in Sunday we can see about a classification project, and the next day we can go with a regression project, and then moving into clustering or unsupervised learning. Okay, that will be the plan. So now I'll show you the assignment 2. Today is day 10. So in day 5 I have given you an assignment. So many people have submitted it. Very good. So please continue doing it. Okay, it's for your own good. So the assignment 2, it's very simple. Can we see about this assignment 2? It's mandatory. You have to do and submit this one. And you can find the link in the video description. Okay, when you see below, you can find the link, or you can download it directly from Kaggle. It is car dataset. You have to download it, and you can perform the exploratory data analysis. Okay, So this data analysis may include using pandas and visualization tools. Okay, you can do the exploratory data analysis and you can tell what is the features in the car dataset. This is a used car dataset. Just now we have seen, right? Okay, you have to do the exploratory data analysis and then you have to perform the pre-processing, which all required. The pre-processing may include handling null value if present, scaling the value, or if it is a text data you have to encode it, okay, into numerical format. You want to select what are the important features and you have to select the X and Y. Y will be the output, that will be the price of the car, and X will be the features. And you have to perform train test split module. Okay, once you've done that, you can get the X train and Y train separately, right? So please keep till that. Next step will be going into the algorithm, right? So we can do it later on. Clear about the tasks for this assignment 2. So once you complete this, you can just take screenshot of the outputs for these all tasks, okay? Or you can attach the file or take the screenshot. If you can't attach the photo separately, you can just go and store it in some PDF and then upload it as a PDF itself. No issues. Clear? For the assignment submission form, it will be actually available in day 7, I think so. You can check that video in the live chat, it will be given. Is it clear, guys, regarding this assignment? Can I get thumbs up? Can we wind up today's session? If you guys have any doubt, you can ask it now or we can see in tomorrow's class. So the steps in EDA you have to decide. So it's your creativity. You are, like, for example, you are working in a company, you are a data scientist and they are giving you to analyze this data and do the process. And you want to explain the client about it. What will you do actually? You want to explore and understand the data, right? So I don't want to see the rows and columns. If I go just do if I see the EDA alone, I should get what all things present are, what is the trend. So you have to actually imagine and what will be the best you have to give it. Please try to make use of it, okay? So this is a weekend, right? Saturdays and Sundays, I'll give you 2 days time for this assignment. Try to complete before Monday. So you are having enough time. So take your time, just do this process. Okay? That's it, guys. Thank you. Thanks for watching. We'll see you in tomorrow's class. We'll continue with seeing the math behind the algorithms, how it is working in tomorrow's class.